Assalamualaikum and good morning. I would like to present my mini project on EFT1065 algebra. My name is Erickson bin Masudin, metric no J22A0086. Question 1. Arif plays FPGA soccer. He makes a goal 65% of the time he shoots. He is going to attempt 2 goals in a row in the next game. A. The event Arif is successful on his first attempt. PA is 0.65. B is equal to the event Arif is successful on his second attempt. PB is equal to 0.65. Arif turns to shoot in streaks. The probability that he makes the second goal given that he made the first goal is 0.90. Question A. Find the probability that he makes both goals. To find the probability that Arif make both goals, we need to calculate the joint probability of the events A and B. Since Arif turned to shoot in streaks, the probability that he makes the second goal given that he made the first goal PBA is 0.90. Using the formula, PBA is equal to PA and B. We got 0.90, so we can rewrite the equation as PA and B. PBA multiplied by PA is equal to 0.90 multiplied by 0.65 equal to 0.585. So we got the probability that Arif make both goals is 0.585. Next, B. Find the probability that he makes either first goal or the second goal. The probability that Arif makes either the first goal or the second goal is equal to the sum of the probabilities that he makes each goal, taking into account that the two events are not mutually exclusive. He could make both goals. Therefore, the probability that Arif makes either the first or the second goal is given by PA or B equal to PA plus PB minus PA and B, where PA is the probability of making the first goal, 0.65. PB is the probability of making the second goal, 0.65. And PA and B is the probability of making both goals, 0.585, which we calculated in the previous answer. Substituting the values, we get 0.65 plus 0.65 minus 0.585, and we got the answer 0.68. So the probability that Arif makes either the first or the second goal is 0.68. C. Are A and B independent? The answer is no. A and B are not independent events. Independence between two events means that the probability of one event happening is not affected by the occurrence of the other event. In this case, if Arif makes his first goal, event A, the probability that he makes his second goal, event B, becomes 0.90 instead of 0.65. This shows that the occurrence of event A will affect the probability of event B, indicating that A and B are not independent events. Next, D. Are A and B mutually exclusive? And the answer is no. A and B are not mutually exclusive events. Mutually exclusive events are events that cannot both occur at the same time, meaning that if one event occurs, the other event cannot occur. In this case, it is possible for both events A and B to occur, as Arif can make both of his atoms. Hence, A and B are not mutually exclusive events. Question 2. The mean hourly earnings Y in Ringgit Malaysia of employees at outpatient care center in Malaysia from 2015 to 2020 can be modeled by Y is equal to 0.282 T plus 15.2 and 0 less or equal to T less or equal to 5, where T represents the year with T equal to 0 corresponding to 2015. Illustrate the model to estimate the year in which the mean hourly earnings were 16 ringgit 75 cents. First, we got Y is equal to 0.782 T plus 15.2. So we can solve for T when Y is 16.75. Substituting the value to the equation, 16.75 is equal to 0.782 T plus 15.2. We got 1.55 is equal to 0.782 T. After going to divide, we got T is 1.98. Since T represents the year with T equal to 0 corresponding to 2015, we can convert T 1.98 to a year by adding 2015. So we can add 1.98 plus 2015. We got the year 2016.98. Since in a year we cannot use any point answer, so the estimated year in which the mean hourly earnings were 16 ringgit and 75 cents is 2016. Question 3. Company A SDN PhD wants to maximize the profit for porcelain crucible and platinum crucible. Porcelain crucible yields a profit of 1.50 ringgit per unit, and the platinum crucible yields a profit of Rm 2 ringgit per unit. The constraints are: first, the combined production level should not exceed 1,200 units per month. Second, the demand for platinum crucible is no more than half the demand for porcelain crucible. 3. The production level of porcelain crucible is less than or equal to 600 units plus 3 times the production level of platinum crucible. So the question A is: model the equation for maximize profit and each constraint involved. The equation for maximizing profit is: maximize Z is equal to 1.5 P plus 2Q, where P is the production level of porcelain crucible and Q is the production level of platinum crucible. The constraints are: 1. The combined production level should not exceed 1,200 units per month. We got P plus Q less or equal to 1,200. Second, The demand for platinum crucible is no more than half the demand for porcelain crucible. We got Q less or equal to 0.5 P. Third, the production level of porcelain crucible is less than or equal to 600 units plus 3 times the production level of platinum crucible. So we got P less or equal to 600 plus 3Q. These constraints can be represented in the form of linear inequalities. The objective is to find the value of P and Q that maximize the profit set subject to these constraints. In this is a linear programming problem. B. Draw graph based on 3A. After drawing a graph, I got the graph look like this. Next question, C. Find the optimal production level for porcelain crucible and platinum crucible. We got the maximized profit. Z is equal to 1.5 P plus 2Q. Subject to constraint, P plus Q less or equal to 1200. Combined production level. Q less or equal to 0.5 P, demand for platinum crucible. P less or equal to 600 plus 3Q, production level of the porcelain crucible, where P is the production level of porcelain crucible and Q is the production level of platinum crucible. Solving this linear programming problem with these new variable names, we get the optimal production level of P is 450 and Q is 750. Therefore, the company should produce 450 units of porcelain crucible and 750 units of platinum crucible to maximize profit, yielding a total profit of Z. So we have to multiply 450 multiplies 1.5 plus 250 multiplied by 2, so we got RM 2,175 ringgit. Question 4. An architect draws a plan of UMK hall with 15 seats in the first row, 18 in the second row, 21 in the third row, and so on. If the hall is to have a seating capacity of 670, calculate the number of rows must be drawn by him. Let's say A1 is 15, A2 is 18, A3 is 21. And we got the D, the difference is 3. So we use the formula Sn is equal to Na1 plus as I write here, this is the formula, and substituting the value, and we solve to find the n. So we got the n value is 17.1 or negative 26.1, but we ignore the negative values and we take the positive value, so the number of rows must be drawn by him is 18. That's all from me, and thank you.